All right, we're gonna do a couple more properties. This is what if there's a number in front of the x squared. So to start this thing off, let's just graph y equals x squared. Oops, I gotta get a pen here. Hang on one sec. There we go. Now I should be able to draw. Give me any color. What color do we have? Green. Okay. So we're subbing in here. We sub in 3, same as before. 9. 2 squared is 4. We want to get really good at graphing. 1 squared is 1. 0 squared is 0. Minus 1 squared is 1. 2 minus 2 squared is 4. Now, when it says graph, make note of the step pattern. We said we're getting good at the graph in this. I put a dot at 0, 0. I go over 1, up 1. So I'll make note of the step pattern after. Then I go over 2, up 4. Over 2, up 4. And then I'm going to try and graph this in green. We'll look at the step pattern in a minute here. Again, not super amazing, but I'm trying to do it with the mouse here. There we go. Okay, hopefully yours is a little bit smoother here. Now, I'm going to quickly change my pen to make note of the step pattern. For this, we always go over 1, up 1. Then if from this point we go over 1, up 3. Now most people get confused with this, so that when they've got an A in front, when they've got a number in front, they usually just do 3-point accuracy because it makes it easier. Over 1, up 1, over 1, up 3. Same with on this side. Over 1, up 1. Over 1, up 3. Okay, let's at least remember this over 1, up 1 bit here. Because what's going to happen is we're going to get this 2 in front. Okay? And it's going to affect the step pattern. So let me graph y equals x squared quick. Put a dot at 0, 0. I can't really see it. Dot at 1, 1. Dot at 1, 1. Over 1, up 1. Over 1, up 3. Over 1, up 3. Here is my y equal. Now this one, accuracy is a little bit more important, so I'm going nice and slow to try and get this good. There we go. Now, let me change my pen and show you what's going to happen before I switch to Desmos to prove it this time. Up here where we said the step pattern, over 1, up 1. This 2 is going to double my step pattern. So instead of over 1, up 1, it's going to go over 1, up 2. And this is going to be a whole bunch skinnier. Then here where we go over 1, up 3, it's going to go over 1, up 1, 2, 3, 4, 5, 6. It's going to double it. So if I were to graph this, 0, 0 stays here. I didn't do a super great job, but the idea is it's going to be 2 times skinnier. Or our textbook is going to say 2 times stretched. Ooh, that side looked bad. I'm going to open it up in Desmos in a minute. So this one will be 3 times skinnier. Instead of over 1, up 1, it's going to be over 1, up 3. Let's take a look in Desmos. Okay, here's y equals x squared. I'm going to delete these brackets. Oops. Put an x back here. Now we're putting a number in front. If we look, here's over 1, up 1, right? I'm going to put a 2 in here. That changed from over 1, up 1 to over 1, up 2. There's my y equals 2x. If I put a 3 in front there, over 1, up 3, it's 3 times as skinny. Now, at the bottom of this page here, or at the end of this one, it says 0.3. It works the exact same. Instead of over 1, up 1, it's going to be over 1, up 0.3. So it's going to be just a bit wider. Let's try doing that one now. There we go. Over 1, up 0.3. So it's gotten wider instead of getting skinnier. So if it's a 0 point something or a fraction, I guess you could have a fraction with a higher numerator than denominator. So if it's a fraction that's less than 1, it's going to make it wider. Or a decimal that's less than 1 but bigger than 0, it's going to make it wider. Okay? So we should be able to take the rest of these questions and predict what's going to happen here. This one's going to be 3 times skinnier. This one's going to be 0.3 wider. They call that in the textbook compressed. This one is going to be, it'd actually be compressed by a factor of 2. It would be a stretch by a factor of 0.5. So if we just say wider and skinnier, that might show that you understand it a little bit better. This one's going to be skinnier by a factor of 6. This one's going to be wider, 0.6. Okay? There's one more thing that we've got to learn here, and it's what happens if we throw a minus in front. Let's just look on Desmos, see what that minus does. Now, we might have an idea already of what this does, because the one thing we haven't seen, we've talked about how a quadratic can be a valley or a hill, and we haven't seen any hills yet. That minus in front is going to flip it upside down. So if we have a 2 in front, it's going to flip it upside down and make it skinnier. If we have a 0.5, it's going to flip it upside down and make it wider. So, right at the bottom of the page, I would suggest playing with this a little bit more. I would have Desmos open, sketch all the things that you learn right here on your graphs, and then right at the bottom it says make a note of it. What happens when there's a number in front? I would put something to the effect of the number makes it, if the number's bigger than 1, it makes it skinnier by that factor, or stretched by that factor. If it is less than 1, it compresses it, or it makes it wider. The negative sign flips it upside down. So I would finish off these. There's some good homework questions that you can try out, and hopefully that helps. Those are all the ideas. The next lesson I'll just be putting all these ideas together. Seeing each of those, it may look a little bit scary, and then doing all the shifts. All right, hopefully that helps.